Hello everyone, welcome to my channel on learning field. Today in this topic we'll learn how to derive electric field due to an electric dipole at a point on the equatorial line. To prove this derivation, first of all we need to draw a diagram relating to this topic. So first of all we need to draw a diagram relating to this topic. Draw a line towards the middle portion of the page and cutting its origin, draw another line. By drawing this line, notice that the two lines should be equal. Then join the point. Let this point be named as Q and this point named as O. And join these 2 points. Let this point be named as B and join the points. Let this point be A and join this point also. After joining the lines, we have seen that let this point be minus Q charge and this point be plus Q charge. The distance between A to O is D, is taken as D, and the distance between O to B is also taken as D. Then the distance between A to B will be twice D. After drawing this one, now we have seen that it makes an angle theta. This angle QAO makes an angle theta, or you can say OAQ. This angles also makes an angle theta. We all know that. Suppose we extended a line from here towards the to a perpendicular to point Q, and we have seen that these lines can be extended towards the straight surface, and we need to join these points. We have extended a line towards the perpendicular to point Q, and we have joined the point E and N. We have named these points as M, E, N, and we know that this is the electric field E1 and this is the electric field E2, and the distance between Q and O is R. Now first of all, let us write the consideration part. Let AB be an electric dipole of length twice d. Let AB be an electric dipole of length twice d. P be the dipole moment. Q is a point on the equatorial line. Q is a point on the equatorial line. We know that equatorial line means what? We already know what is equator and what is equatorial line. And line at a distance. Q is a point on the equatorial line at a distance r. From the midpoint O of the dipole we have considered. Now we can write the derivation part. Electric field at a point. Electric field at the point Q. Due to the charge plus Q. Electric field at the point Q due to the charge plus Q. due to the charge plus q of the dipole can be written as E1. This is the E1 line, isn't it? So E1 will be equals to, E1 is equals to, since we know the formula of electric field, we can use in this derivation. Since electric field formula is equals to 1 by 4 pi epsilon naught into q by r square. Since we know this one, by applying the formula here, we came to know that E1 is equals to 1 by 4 pi epsilon naught q by bq square. bq square. Since the distance between this one is bq, so we have considered bq square. After this, we need to write that like this. Therefore, which is equals to, E1 will be equals to 1 by 4 pi epsilon naught into q by the distance between bq. The distance between bq we have considered, we have not considered till now, since we have wrote that q by bq square. Since we have wrote q by bq square, now we need to find the value of bq. What is the value of bq here? We can find the value easily. Look here carefully, please. By applying Pythagoras theorem in this triangle, we can find the value of bq. So we can find the value of bq as, since in the Pythagoras theorem we have learned in class 10 maths that AC square is equals to AB square plus BC square. So by applying this formula in the given triangle, we can find the value of bq easily. We can see that bq square is equals to bq square. Since this is the hypotenuse, look here, this is the perpendicular, isn't it? Perpendicular opposite is hypotenuse. This is the hypotenuse, so bq square will be equals to r square plus d square. Now bq will be equals to root over r square plus d square. We know that, isn't it? Now this one is not needed here, because we no need to find the value of bq. Since we need the value of bq square, so directly we can substitute this value, isn't it? So we can write here r square plus d square. Therefore we can write electric field E2 due to the charge plus q on the point q is given as. Now look at the diagram carefully. Electric field at the point q due to minus q. We have found the value of electric field due to the point q, due to plus q we have found. Now similarly we need to find the value of minus q at the point q due to minus q. Now similarly you can find easily, isn't it? So E2 will be equals to 1 by 4 pi epsilon naught into q by similarly in this diagram, what is the r here? R is aq. So aq square. Since we know the value of formula of electric field, you can look here again. Since electric field is equals to 1 by 4 pi epsilon naught into q by r square. So by substituting the value of r square, since here r square is equals to aq square, so we can write here AQ square. Now similarly, by using Pythagoras theorem, you can find the value of AQ square in the required diagram. Since here we have found that R square plus D square. Similarly, you can find if you understand clearly. So which is equals to 1 by 4 pi epsilon naught into Q by R square plus D square. Because therefore E1 will be equals to E2, isn't it? E1 is equal to 1 by 4 pi epsilon naught into Q by R square plus D square, and E2 is also is equals to 1 by 4 pi epsilon naught into Q by R square plus D square, isn't it? So E1 will be equals to E2. Now resolving E1 and E2 in this corresponding components we get the vertical component E1 and E2 sin theta are equal and opposite. Since I have already told you are equal and opposite, and hence if they are equal and opposite, what will be the solution? Since they are equal and opposite, E1 is equals to 1 by 4 pi epsilon q by r square plus d square, and E2 is equals to 1 by 4 pi epsilon naught into q by r square plus d square. Since these two resolve it and they cancel each other, hence cancel each other. Therefore we can write that the resultant electric field at the point Q due to the dipole is. Now look at the diagram carefully. I have provided in this video. Since we know from before that since they are equal and opposite, they will cancel each other, since we know from before. But we need to find the vertical component, horizontal component and vertical component. Since resolving E1 and E2 in these corresponding components, we get the vertical components E1 and E2 sin theta are equal and opposite. Since they are equal and opposite, we need to find the resultant electric field. So to find the resultant electric field, we have considered that this E1 electric field is going this side and E2 electric field is this side. So this is the resultant electric field E. The angle between them is theta and theta. So this angle is also theta we have considered, and this angle also we have considered theta. So these angles is cancel each other, then are not need, and we need to consider that second angle, that is cos theta. This is sin theta and this is cos theta. Horizontal component, vertical component. Okay. Therefore we can find that E is equals to E1 cos theta plus E2 cos theta. This is the resultant component, remember. Since we know that E1 is equals to E2 from before we have proved, isn't it? E1 is equals to E2. Let it be equation number 1, suppose. Then it will be E1 is equals to E1 we can consider E1 cos theta plus E1 cos theta, because we know that E1 is equals to E2 from 1. Okay. Now we can find that E is equals to twice, because E1 plus E1 is 2, we know that. So 2E1 cos theta. So we can find that E will be equals to twice. Now what is the value of E1? Find the value of E1. we know that the value of E1 is 1 by 4 pi epsilon naught into q by r square plus d square. By resolving the vertical component, we have found this value. Now substitute the value here. E into 1 by 4 pi epsilon naught into q by r square plus d square. Cos theta is there, so we write here. After finding this, we need to write E is equals to, now look here, now we need to find the value of cos theta. Now we need to find the value of cos theta. How will we find the value of cos theta? Similarly, by applying the Pythagoras theorem, we can find the value of cos theta. Cos theta will be equals to, write it down in the rough work. Cos theta will be equals to, by using Pythagoras theorem you can find easily. Since you have learned from the from class 10 maths, Pythagoras theorem proof you have already learned, so we can find the value of cos theta. Cos theta is equals to d by root over r square plus d square. By finding the value of cos theta, you will get this value. Now substitute that value here. So E will be equals to 2 into 1 by 4 pi epsilon naught into q by r square plus d square into, we know that cos theta value is what? By applying Pythagoras theorem, we can find the value of cos theta. Cos theta will be equals to d by root over r square plus d square. Since we can write that E is equals to 2 into 1 by 4 pi epsilon naught into q by, since we know that, look here, these two you look, okay, this one and this one you look, since r square plus d square, into is there, isn't it, 1 by is there, isn't it, 1 by again root over r square plus d square is there. So after resolving these two, we came to know that, suppose there is twice d, okay, suppose 1 is there, okay, then after resolving it, look here, r square plus d square, this is whole to the power, we can take suppose 1, isn't it, suppose 1, then this is already, we know that the value of root is equals to 1 by 2, we know, isn't it. Now we can write, similarly we can write root over r square plus d square into will be, this one will be into 1 by r square plus d square to the power 1. We have taken this one as this side. So after resolving this one, we found that r square plus d square plus 1 will be equals to r square plus d square 1 by 2. The value of root we know that 1 by 2 plus 1 will be equals to root over, so since, sorry, it will be r square plus d square into, since we know that half plus 1 will be equals to 3 by 2, we know, you add and you will find that it will be 3 by 2, then it will be 1 by r square plus d square equals to 3 by 2. Okay, the value of this one is 1 by r square plus d square to the power 3 by 2. Okay, by resolving the values, we find that r square plus d square 3 by 2. Okay, now this is the required solution you need to find, hence proved, it is derived also. Now we'll find now I'll discuss about the next topic, that is electric flux. Now what is electric flux? From the ready-made notes, I'll discuss about electric flux. You can note down this electric flux also. Now what is electric flux? Electric flux means what? To know the concept of electric flux, first of all we need to draw a diagram. After drawing the diagram, the electric flux, this is the electric field, and this is the distance travel, and this is the angle theta. This is the small angle ds. Okay. Now, the electric flux is defined as the total number of electric field. It is defined as the total number of electric field. How many number of electric field we of total number of electric field lines? These are the lines crossing through the given area. Crossing through the given area. It depends upon the total number of electric field lines crossing through the given area. That means we can define electric flux as electric flux is defined as the total number of electric field lines crossing through the given area. Now remember that, always don't forget this one, electric flux is a denoted by phi. This is the symbol of phi. Now electric flux is a scalar quantity. Electric flux is a scalar quantity. Scalar quantity means what I have explained in the previous video. You can watch and see what is meant by scalar quantity. Now its SI unit is Newton meter square per coulomb. We can find out the SI unit easily, isn't it? You have already learned from class 11. So the SI unit of electric flux is Newton meter square per coulomb. We can find out through this formula also. D phi is equals to electric field into area, since it is defined here already. If you remember the formula, you can define it easily. Now electric flux will be equals to electric field into area. Whether this area is small amount or it is present in large amount, it does not make any difference here, since we are finding the formula. Now remember that electric flux is always is equals to electric field into area. Now the next topic is charge densities. Now what is charge densities? We know that charge is positive, maybe positive or negative, and charge is always present in small or large amount, isn't it? Now we have not found the we have the smallest quantization of electric field. We have know that, isn't it? We have learned from the previous sections. Now what is charge density? Charge density of three types. Actually here in this chapter it is of three types: linear charge density, surface charge density, and next page volume charge density. Now linear charge density means what? Linear means already we know it is a straight line passing through the axis, isn't it? We have learned already in the maths, isn't it? Linear means what? It is passing through the straight line. Now charge densities. Density means what? Density mass by volume, isn't it? Mass by volume. Charge means already we know it may be positive or negative. It carries some charge. So okay, linear charge density. Now what is linear charge density? Linear charge density means it is defined as the number of charges. It is defined as the number of charges present per unit length. Number of charges per unit length. Linear charge density depends upon length. Linear charge density always depends upon length. Charge by length. Remember that. Linear charge density means charge by length. Lambda, it is denoted by lambda. Lambda is equals to Q by L. Now what is surface charge density? Surface charge density, we know that surface means, suppose this is a plane surface. This is a plane surface. Now this is also a surface, isn't it? Surface charge density. It is defined as the number of charges present per unit surface area. Surface area means what? Area, just area, A. Okay, next page you'll find it. Now look here. Sigma is equals to sigma, or you can write sum over same thing, Q by A. So next topic is volume charge density. Now what is volume charge density? Volume means we know, isn't it? Charge density also we all know, and it is denoted by gamma. So it is defined as charge per unit volume. So easy, isn't it? The next topic will be discussed in the next session. So please subscribe, share, and like and comment my channel to view the, and please press the notification bell to view all the videos related to these topics. Thank you.